Hello, welcome to lesson 5.1b, solving quadratic trigonometric equations. Today we're actually going to start this with a quick review of just solving trig equations. It might be a good idea to pause this video and try this one on your own, but I'm going to get started with it right now. Alright, so solving trig equations. If I wanted to solve this equation here, I'd probably want to get sine by itself first. So 2 sine of x would be -1, which means sine of x is -1/2. And then to find all the solutions, I just need to find where sine of x is -1/2 on the unit circle. Turns out it'll be equal to -1/2 here and here, because sine is the y value, and those are the two spots on the unit circle I've got a y value of -1/2. Now there's going to be an infinite number of times that I could land at each of these spots. So that angle there is an angle of 7 pi over 6. So x could be 7 pi over 6 plus 2 pi k, indicating all the times I could land there, right? I could land there right away, or I could go once around and land there, or twice around and land there. We talked about that in our last video. So all infinite times I could land on that angle would be written with that expression. But I could also land on this other angle right here. So that also has a y value of -1/2. And that angle is equal to 11 pi over 6. So x could also be 11 pi over 6. Plus again, 2 pi k to indicate all infinite times I could land there. Those are the two sets of infinite solutions for this equation. All right, today we're going to learn about solving quadratic trigonometric equations. Quadratic equations are ones that have an x squared. So this is an example of just a regular old quadratic equation, which we should probably do a quick review of how to solve that, because solving one that involves trig is going to be very, very similar. So if I asked you to solve that equation, hopefully most of us would look at that and be like, oh yeah, no problem. We need to factor that thing. The way we could factor this particular one would be 2x plus 1, I believe, times x minus 1 equals 0. Yep. Since I've got two things multiplied together to be 0, one of them has to be equal to 0. So if this one was 0, 2x plus 1 equals 0, then that would mean x would have to be a -1/2. And if this one was 0, then x would have to be a +1. There are my two answers for that quadratic. All right, now we're ready for today's stuff. Today's stuff is we're going to solve quadratic equations, but this time they're going to be quadratic trigonometric equations. In other words, quadratic equations with a squared, but involving trig functions, not just an x. Turns out, solve these the exact same way we solve any other quadratic equation. We see if we can factor it. This is 2 times something squared minus that same something minus 1. That's just like, I'm going to rewrite this as a variable. If instead of writing sine squared, if I wrote this as 2m squared minus an m minus 1, then it's exactly like this one here that we just did. It factors. That one factored into a 2x plus 1 times a 2x minus 1. If I had an m there, it would factor into the 2m plus 1 times an m minus 1. Right? The thing is, it's not really an m. It's a sine. It's 2 sine squared minus sine. So some people like writing this stuff here as just a method of helping them factor it. They'll just change that sine into an m, and then they'd say, oh, that's how I factor it. And some people prefer skipping straight to this part here. But regardless, since they're the same function, just a different variable name, they factor the same. The only difference between this one and that one is with this one, my variable is m, and with that one, my variable is sine of x. So this one up here is going to factor into 2 sine of x plus 1 times sine of x minus 1. Just the same as that one factored. So when you do this, if you have a quadratic equation that involves trig functions, like that, you can factor it, just like that, the same exact way you would factor it if it was a variable like m or x or anything else. If you want to write this part in pink to help you factor it, go for it. If you want to skip straight to this part, go for it. Both works. Either way you do it, you eventually get here, and then you say, well, I've got something times something else equals 0, so one of those things has to equal 0. If it was this one, 2 sine of x plus 1 equals 0, then sine of x would be negative 1/2. And I would look at my unit circle and find out where that happens. That happens here and here when the y value is negative 1/2, just like we did before. For this one, if sine of x minus 1 equals 0, then that means sine of x would be 1, and that happens right here when the y value is 1. Now, all you need to do is write out your answers. There are 3 sets of infinite solutions. So from this one on the left, I'm going to write that in red just to color code it. X could be this angle, which is 7 pi over 6 plus 2 pi k. Or it could have been this angle, 11 pi over 6 plus 2 pi k. Or I might have been this one over here, sine of x equal to 1. That happened right here again. That's at pi over 2. So, or x might have been pi over 2 plus 2 pi k. There are all of my answers. Feel free to leave your answers like that. That is correct. When you do your homework, the back of the book might write them in a little different way. As long as you know they're equivalent, you're good to go. Speaking of writing them in different ways, there was a more efficient way I could write it. We talked about an efficient way of writing our answers in the last video. But for this particular one, since these are all evenly spaced, I could write all 3 of these answers in just one solution set. I could say x equals pi over 2 to have that to land in this first one. And since those 3 angles are all evenly spaced, I could just figure out what it takes to land at this one, and then that one, and then that one. A circle is 2 pi. I want to go 1/3 of the way. So if I add 2 pi over 3, that'd be 1/3 of a circle, and I add it k times, that answer is equal to all 3 of these combined, because it starts on this one up top, then adding 2 pi over 3 would land me here, adding 2 pi over 3 would add me there, and 2 pi over 3 would bring me back up to the top. So if you wanted to do that, it's kind of fun to be able to figure out a more efficient way to write your answer. You can't always do it, and you don't have to do it. But if you wanted to write that, there is an equivalent answer to all 3 of those ones on the right. All right, let's try this one more time. Solving the equation 2 cosine squared of x minus 7 cosine of x plus 3. This is a quadratic equation. We can factor it. If you're not sure how to factor it, again, it might not be a bad idea to change the variable to something else just as a placeholder, right? Instead of writing 2 cosine squared, you could write 2, let's use m again, 2m squared. Minus, instead of 7 cosine, I could write 7m plus 3. Sometimes it's easier for students to figure out how that factors. All right, that one would factor into 2m and an m. The 3 is definitely going to go here because 3 times 2 is 6. The 1's there, so when I add them together, I'll get 7. And since that's a negative 7, these both have to be negative. All right, if that's how it factors with when it's an m, when you factor it with a cosine, it's going to factor in the exact same way. Just instead of a 2m, it's going to be 2 cosine. And instead of m, it's going to be cosine. All right. From this one, if that was equal to 0, oops, that should have been just a cosine, not cosine squared. There you go. If that was equal to 0, then cosine would be 1/2. And I can find out when that happens. Let's highlight that. That's when the x value is 1/2. That happens right here and right there. If I looked at this one, that's when cosine of x minus 3 equals 0. That happens when cosine of x equals 3. Cosine of x never equals 3. The biggest cosine can get is 1, right? This is a unit circle. The biggest number I can get to is 1. That never happens. So there is no answer that stems from this. So really I only have two answers. Well, two sets of infinite answers. One right here at an angle of pi over 3 plus 2 pi k for all infinite times I land there. And another one right here, 5 pi over 3. Since those aren't evenly spaced, there's no equivalent way of writing it. I just have to write it both those ways. All right, that's it. Your assignment is just 4 problems. Practice doing them. If you have questions, as always, see me during my office hour. I hope you have a great day. Bye-bye.